Okay guys, let's begin with the discussion of the questions on conic sections. First question says, if the common chord of circle C with center at 2, 1 and radius r and the other circle is the diameter of the second circle, what is the value of r? Talking about circle C, center is given to you as 2, 1 and radius is r, so the equation will be x minus 2 whole square plus y minus 1 whole square equals r square. Simplify this, you get x square plus 4 minus 4x plus y square plus 1 minus 2y minus r square equals 0, which eventually gives you x square plus y square minus 4x minus 2y plus 4 plus 1, that is plus 5, minus r square equals 0. This is one equation of circle 1 and then this is the equation of circle 2. Equation of common chord, you know it is given by S1 minus S2 equals 0. This is S1, this is S2, so let's write it down. X square plus y square minus 4x minus 2y plus 5 minus r square minus x square minus y square plus 2x plus 6y and minus 6 equals 0. So x square y square minus x square minus y square, then you have minus 4x plus 2x, which gives you minus 2x, minus 2y plus 6y, which gives you plus 4y, and plus 5 minus 6 gives you minus 1 minus r square equals 0. Or you can write it as 2x minus 4y plus 1 plus r square equals 0. Now if this is the diameter of the second circle, it is given to you that the common chord is the diameter of the second circle, definitely it is going to pass through the center of the second circle. If this is the equation of the second circle, its center very clearly is 1, 3. So this is going to actually pass through the point 1, 3. So the 1, x equals 1 and y equals 3 is going to satisfy the equation of this line. So what are you going to get is 2 into 1 minus 4 into 3 plus 1 plus r square equals 0. Fine. This gives you 2 minus 12, that is minus 10 plus 1 plus r square equals 0, or r square equals 9. Minus 10 plus 1 is minus 9, r square equals 9. R is coming out to be definitely 3. So the value of r in here is 3. Clear? Moving on to the next question, we have length of the intercept made by any circle on the coordinate axis are equal if the center lies on which line? Okay, so if directly it is evident to you that I am talking about the length of the x-intercept and the y-intercept, you know that length of x-intercept is given by what? If I am talking about the general circle, x square plus y square plus 2gx plus 2fy plus c equals 0. In that case, what is the length of the x-intercept? It is twice of under root g square minus c. We've done it, right? What is the length of the y-intercept? It is given by twice of under root f square minus c. If these both are given to be equal, you basically are getting g square equals f square, or I can say minus g whole square equals minus f whole square. So what is the equation? It is nothing but x square minus y square equals 1, right? Equals 0. This is x square equals y square, talking about the locus. X square minus y square equals 0, or x square equals y square, you can say. So x square minus y square equals 0 actually happens to be my equation. Moving to the next one, we have circles touching x-axis at a distance of 3 from the origin and having intercept of length 2 root 7 on the y-axis. So the situation basically is that the circle is there which is touching x-axis at 3 units, and these are 2 points 0, y1, 0, y2. Clearly the y-intercept is given as 2√7. If I am talking about the center will be obviously 3, k. Fine. Now, if this is 3, k is the center, the equation of this circle is x minus 3 whole square plus y minus k whole square equals mod k whole square. Right? I can get the same circle like this. Fine. So here, this particular circle is basically touching the y-axis at 0, y1 and 0, y2. Right? If it is touching 0, y1 and 0, y2, first of all just simplify of basically if this circle is passing through the y-axis at 0, y1 and 0, y2, this implies y1 and y2 satisfy what? What do they satisfy? In place of x you put 0, in place of y you put y1, in place of x you put 0, in place of y you put y2. So they are going to satisfy 0 minus 3 whole square, which is 9, plus y minus k whole square equals mod k whole square, which is 9 plus y square plus k square minus 2ky equals mod k square. This gets cancelled. You have y square minus 2ky plus 9 equals 0. Both y1 and y2 are going to satisfy this equation, right? The moment I am saying y1 and y2 are going to satisfy this equation, that means they are the roots of this equation, right? Therefore, sum of the roots is minus b by a, which is 2k, and product of the roots is c by a, that is 9. Now you are given the intercept is 2√7. That means mod of y1 minus y2 is 2√7. When you square it, you can alternatively write this as y1 plus y2 whole square minus 4y1 y2. This is given as 2√7. This whole square equals y1 plus y2 is 2k whole square, which is 4k square minus 4 into 9, because y1 into y2 is 9. Now this gives you 28 equals 4 common k square minus 9, or you get k square minus 9 equals 7, or k square equals 16, or k equals plus minus 4. When you put k equals plus minus 4 in here, the equation of these circles which are at a distance of 3 from the origin and have intercept of 2√7 on the y-axis is actually given by this and this. You can just put k equals 4 and minus 4, expand this up, and you are going to get the equations as A and as C. Moving on to the next one, we have, what is it? So there is a circle given to you and a parabola y square equals 4√5x. So 4ax, the standard form, a is given to you as √5. Talking about tangent is what they are doing. I am saying an equation of a common tangent to this curve is this. Okay, so here parabola is given, circle is given, talking about a common tangent. Now see, if I am talking about the parabola 4ax, so this is A. Its tangent's equation is given by what? Y equals mx plus A by m. This is the equation of tangent to the parabola. If the same line has to be the tangent to the given circle as well, that means what should happen is, now this is the circle which is basically passing through origin. Right, so center is not passing through origin, but this is a circle which has center as the origin. So if I want this line to be the tangent to this circle, what should happen? The condition is for this line to be the tangent to this circle, the perpendicular distance of the center from this line should be equal to the radius of the circle, which is what? √5 by √2, because you can write this as x square plus y square equals √5 by √2 whole square, right? And therefore, for this line to be a tangent to the circle x square plus y square equals root 5 by root 2 whole square. What should happen is perpendicular distance of this line from the center should be equal to the radius. That means mod of m into 0 minus y, so 0 plus root 5 by m whole upon under root m square plus 1. Right? This should be equal to root 5 by root 2. Clear? This is going to give us the exact condition on m, which is going to make the tangent to the parabola also a tangent to the circle. So you get root 5 by m. So this is root 5 by m into root over m square plus 1 equals root 5 by root 2. Square both sides obviously, or you can just do this, that root 2 is equals to m into root over m square plus 1. Root 5 gets cancelled out. When you square, you get 2 equals m square plus 1. So this gives you m to the power 4 plus m square minus 2 is 0. Okay? You can write this as y square plus y minus 2 equals 0. When you find out the value of y, you get minus 1 plus minus root over 1 minus 4 into minus 2 whole upon 2. This gives you minus 1 plus minus 3 by 2, which gives you what? Minus 1 plus 3, that is 2 by 2, that is 1, and minus 1 minus 3, that is minus 4 by 2, which is minus 2. I know y is coming out to be 1 and minus 2, but y is actually m square, and m square can never be negative. So therefore you get m square is 1, and therefore m is plus minus 1. If m is plus minus 1, the equation of common tangent is going to be y equals x plus root 5 and y equals minus x minus root 5. So yes, y equals x plus root 5 is one of the equation of common tangent to the parabola and the circle. And also y equals mx plus root 5 by m is their common tangent, then m is going to satisfy this equation. So yes, m is plus or minus 1, which definitely satisfies this equation, and therefore both are true. Moving to the next question, we have, I am saying let P be this parabola y square equals 2x. If three distinct normals of P pass through h comma 0, then h is greater than 1. And if h is less than equal to 1, then exactly one normal of P passes through h comma 0. For this you should be aware that this is the standard equation of the parabola y square equals 4 into a into x. Equation of normal is given by what? Y equals mx minus 2am minus am cube. A is what? M you don't know. Okay, so A is what? Mx minus 2 into A is 1 by 2. So this is just m minus 1 by 2 m cube. Now this normal is actually normal at the point h comma 0. So y is 0 and x is h. So mh minus m cube by 2. This gives you 2mh minus 2m minus m cube equals 0. Or rather you can say m cube plus or m cube minus 2mh plus 2m equals 0. Now if you simplify this, what you get is m cube, or let me just take out m common, you have m square minus 2h plus 2 equals 0. M is common. So you get m square minus 2h plus 2 equals 0. So here this becomes m square minus 2 h minus 1 equals 0. Now for this particular equation to have three distinct real roots, obviously h minus 1 has to be positive, that is h has to be greater than 1, and this has 3 distinct roots, means there are 3 distinct slopes of which normals are occurring. So I can say yes, 3 distinct normals are going to occur when h is greater than 1. This is true. And only one root is going to occur if h is less than equal to 1. That means exactly one normal is going to occur which is going to pass through h comma 0 if h is less than equal to 1. So this is also true, and therefore both these statements are again true. Moving on to the next question, we have, if the line with the equation x plus y equals 6 is normal to the parabola y square equals 8x at the point a comma b, then mod of a minus b is equal to what? So see, a comma b is a line, a comma b is a point which is satisfying the equation of the line as well as the parabola. So you get a plus b equals 6, and you also get b square equals 8a, right? A is nothing but 6 minus b, so you get b square equals 8 of 6 minus b. This gives you b square equals 48 minus 8b, or b square plus 8b minus 48 equals 0. How can you break this up? B square plus, or let me write, minus 12b plus 4b, or plus 12b minus 4b minus 48 equals 0. Right, because 12 into 4 is 48 and 12 minus 4 is 8. So you get b plus 12 minus 4, b plus 12. Now you know that from here you are getting factors as b minus 4 and b plus 12. This is not possible, b cannot be negative, you get b coming out to be 4. If b is 4, a is going to come out to be 6 minus 4, that is 2. And therefore mod of a minus b very clearly is the integer 2. So 2 is the integer which is equal to mod of a minus b. Let's move on to the next question. We have, if this represents an ellipse but not a circle, then possible values of t are what? Let's see. So they are strictly saying this is not representing a circle, this is representing an ellipse. For this to represent an ellipse, I want this expression to be greater than 0, I want this expression to be greater than 0, and I want these two expressions to be not equal to each other. So first of all, I want t square minus 5t plus 6 to be greater than 0, which is t square minus 2t minus 3t plus 6 is greater than 0, right, which is t minus 2 minus 3, t minus 2 is greater than 0, that is t minus 2 into t minus 3 is greater than 0. Now when I am talking about what are the values of t which are going to satisfy this very inequation of mine, how do I proceed? This is 2, this is 3, right? If I talk about numbers less than 2, for this they are obviously less than 3 as well, so this is negative, so this is positive. Then this is negative, this is positive. So t should belong to minus infinity to 2 union 3 to infinity. Second condition is that the next denominator should be positive. 5 minus 4t minus t square. 5 minus 4t minus t square should be positive, or if you take out minus sign common, t square plus 4t minus 5 should be negative. Right? This happens to give you t square minus 5t minus t minus 5 is less than 0, like this. So this becomes t plus 5 minus 1, t plus 5 is less than 0, so this is t minus 1, t plus 5 is less than 0. Again try to look at this. This is minus 5 and this is 1, right? Over here you are going to see, here you are getting positive, negative and then positive. So your t is belonging to minus 5 comma 1. Also when I am talking about the third condition, That is, these two should be unequal. Basically, third condition that these two should be unequal is implying a very simple thing, that is t square minus 5t plus 6 is not equal to 5 minus 4t minus t square. This is just implying that t is not supposed to be an imaginary number, it definitely has to be a real number. So when you combine all the three situations together, you basically get the intersection to be minus 5 to 1 open interval. And when I am saying that t should belong to minus 5 to 1 open interval so that it satisfies first condition, it satisfies also the second condition and satisfies the third condition. In that case, I can say that is my answer, and you can see very clearly that all the four values are following the very interval minus 5 comma 1 open interval. So A is correct, B is correct, C is correct, and D is correct. Fine. So quickly note all this down and then we are going to move ahead with the next question. Okay guys, let's look at the next question now. We have let f be a strictly decreasing function defined on R such that fx is strictly greater than 0. Suppose this equation basically which is holding is representing an ellipse with major axis along the y-axis, then value of a can lie in which interval or intervals. Now over here fx is greater than 0. For this equation to represent an ellipse, you know that denominator of x square should be less than denominator of y square. So you should basically have f of a square plus 5a plus 3 should be less than f of 3a plus 15. But because f is a strictly decreasing function, x is greater than y implies fx is less than f of y. So fx is less than f of y, that means a square plus 5a plus 3 is greater than 3a plus 15, which is a square plus 5a minus 3a plus 3 minus 15. This is positive, right? So you get a square, this becomes 5a minus 3a is 2a. Now from here you get a square plus 2a minus 12 is greater than 0. Why? Because a square plus 5a plus 3 was here and here it is 3a plus 15. So a square remains the same, 5a minus 3a gives you 2a and 3 minus 15 gives you minus 12. So from here, how are you going to proceed further to actually eventually get the value of a is what the task is. The moment a is obtained, we are going to obtain the interval as well in which it belongs, and hence we are going to conclude the result. So quickly try to understand how do you basically get the value of a to get to the answer. So deal with this and then we are going to move ahead with the steps ahead. So guys, in here the very question basically which is going to talk about determination of the interval in which a belongs basically is what is trying to say. Here you can just make this to be 7a and not 5a. You eventually have x square upon f of a square plus 7a plus 3 plus y square upon f of 3a plus 15, that's the correct thing. And over here therefore what do you have? The correct form is a square plus 7a plus 3 is less than f of 3a plus 15 as f is strictly decreasing. So this becomes a square plus a plus 3 greater than 3a plus 15, which is what? This becomes a square plus 7a minus 3a which is 4a plus 3 minus 15 which is minus 12. Now you can very easily break the term, break the middle term. What would that be? A square plus 6a minus 2a minus 12 is greater than 0, right? So this becomes a plus 6 minus 2, a plus 6 is greater than 0, right? So this becomes a minus 2 and a plus 6 is greater than 0. When on the real line you try to plot this, what do you obtain? You have this over here is minus 6 and somewhere here is 2. You can very easily see if from here you are going to pick up numbers, this will be positive because this will be negative into negative positive. Again from here negative into negative positive, here it will be negative. So your answer is minus infinity to minus 6 union 2 to infinity. So the interval is minus infinity to minus 6 and 2 to infinity. Clear? Moving on to the next question, we have the equation of a tangent to the hyperbola 3x square minus y square equals 3 parallel to the line y equals 2x plus 4 is what? Now this is what hyperbola? You can take 3 in the denominator, you just can say x square upon 1 square minus y square upon root 3 square equals 1. How is the equation of tangent to this hyperbola given? The equation of tangent to this hyperbola is given by y equals mx plus c, where c equals a square m square minus b square. Now the tangent is given parallel to this line. Parallel lines have same slopes. Slope over here is 2, right? It is actually minus 2 by minus 1, so it is 2. Slope is 2, that means m is 2. A square is what? 1. And b square is what? 3. So c comes out to be a square into m square minus b square, which is 1. So c is basically 1. So y equals, m was 2, 2x plus 1. Right? C equals, or I can say c square equals a square m square minus b square. That is the correct thing. So c square comes out to be equal to 1. So c comes out to be plus minus 1. So 2x plus 1 and y equals 2x minus 1. So your answer is y equals 2x plus 1 and y equals 2x minus 1. Now next we have, let E1 be the eccentricity. So the question is basically talking about the eccentricity of hyperbola and the ellipse. So what is given to you is regarding the eccentricities of hyperbola and the ellipse. What is this? This is basically x square by 16 minus y square by 9 equals 1, which is very clearly a hyperbola. Its eccentricity, let us take it as E1. So E1 square equals 1 plus b square by a square, which is 1 plus 9 by 16, which is 25 by 16, and therefore E1 is actually 5 by 4. Talking about the next, we have 16x square plus 9y square equals 144, which is again x square by 16 but plus y square by 9 equals 1, which this time is ellipse. And if I take E2 as its eccentricity, I know that E2 square equals 1 minus b square by a square, which is 1 minus 9 by 16, which is 16 minus 9 by 16, that is 7 by 16. Fine. Now we need to match stuff. So E1 square plus E2 square. E1 square plus E2 square. E1 square is 25 by 16. And E2 square is 7 by 16. This comes out to be 32 by 16, which is 2. So basically A gets mapped to R. Clear? Then you have E1 square upon E2 square. So E1 square upon E2 square, that is 25 by 7. And your answer is that B gets mapped to S. Then it is E1 square minus E2 square. Let's see. E1 square minus E2 square. 25 by 16 minus 7 by 16. So you get 18 by 16. That is 9 by 8. So your answer is that C gets mapped to P. And E1 minus E2 square. What is E1? E1 is 5 by 4 minus 7 by 16. This is E1 minus E2 square. What is this? 20 minus 7, that is 13 by 16, that is Q. So D gets mapped to Q. Clear? That's how we apply all the concepts related to circles, parabola, ellipse, hyperbola to the questions. So practice them very nicely. That's it from my side. Thank you.